Hello everyone, welcome to my channel. So in this video, I will continue my topic explanations of the confidence interval. So in last videos, we already talked about how to use the confidence interval to help us measure what is accuracy of our point estimator. So in that video, we work on the use the sample mean to estimate our population mean for a normal distributed population. And at that time, we said the population mean mu is unknown, but the population variance sigma square is known. So in these videos, we will continue on similar topics, but for this part, all other assumptions is still keep same, but now we say the population variance is unknown. So that means we don't know the value of our sigma square. So in last video, we already say what we want to do is we try to find a probability of L smaller than mu smaller than R is equal 1 minus alpha. So here alpha is a given close value very close to 0. So here by some process of the computations like the standardized of our normal distribution. So you can see more details in our last videos. I will give the link here. So then for this one, what we have is we have the confidence interval. Actually, it can be given by this formula. So here, if you look at this formula, to compute this marginal errors, actually here we use the value of our variance, this sigma square. So because sigma is the population standard deviation, which is the square root of our population variance. So that means when the variance sigma square is known, then this value of sigma is of course also be given. However, in these videos, what we do is we don't know the value of this sigma. So that means if we don't know this sigma, we still want to get this equation. What we can do, a very common idea is we can use some value to guess or to substitute this value of sigma. So here, this one actually have a different way. The first one is if our sample size n is really large, then in this case, we can use our previous central limited theorem to guess the value of our sigma. So here for this part, if you don't know what is a central limited theorem, you should look at my previous videos about the central limited theorem. So anyway, if this n is large enough, so here this means now similar, just parallel with our equation for the confidence interval when variance is known. So the only difference is now we substitute our sigma by this s, which is our sample standard deviation or sample errors here. So here, except this substitutions, all other equation is still same. We still have the left endpoint and right endpoint. We still have the marginal errors. The only difference is just we have the s instead of sigma here. Okay, so this is when n is large enough. So by the central limited theorem, we can have this equation. However, if this n is small, what should we do? So if the our sample size is really small, so here we can still have use this standard normal random normalize of the virus to, and also use this s to substitute our sigma. Unfortunately, not all our standardized equation is not no standard normal random variable anymore. So when this one is not a normal standard normal random variable, what is this? So this actually is a new distribution we want to learn in this section. So this is a T distribution. So we also, someplace they also call this as a student distribution. So here, So here, if you assume this black curve, here is our PDF of our standard normal random variable. And then what we have is, if we draw the PDF of our t distribution, so this actually is a look similar of the black curve here, but the difference is this curve will have a lower peak, but will have a thinner tail. So that means this will look like this red curve. So this is our PDF of our t distribution, or call it as the student distribution. So here for this distribution, generally there is a parameter of this distribution is with a degree of the freedom. So here the degree of freedom actually is just use our sample size minus 1. Okay, so this is about the t distribution. And also just maybe at the back of your textbook, or you just search online, we also have the table for our t distribution. So that means for our previous equation, now try to find our z alpha over 2 will not use a standard normal table, but use a t table. So here, this means what we will have is we will have this equation. So you can know now this the difference is first when the population variance is unknown. So we will use this use the t table to try to find these two values, and then also we should use the sample error s to substitute our original population standard deviation. Okay, so this is how we can find the confidence interval when our population variance is unknown, and also the sample size is really small. So similarly, we can also have one side confidence bounds. So these two confidence bounds, of course, we also have the upper confidence bounds and the lower confidence bounds. For the upper one, so this is still use our sample mean to plus our new this term, second term. So here we also have used this t table to find our value t here, and also we use this standard s, the sample standard deviation s, to substitute the population standard deviation. And so here you need still to careful about the value. So because this is one side confidence bound, so here we will use this alpha, not alpha over 2 for this one side case. And also for the lower confidence bounds, so the idea is still same. You first need to find, here you use this alpha, not alpha over 2. The second is you should carefully use the t table, not the normal standard normal table. And then the third one is we should use the sample value to substitute our population value. Okay, so this is how we can do or try to find the confidence interval when we have requirement. First, we know the population is follows a normal distribution. Second, the variance of this normal distribution is don't know. So we know this is divided to two cases. When sample size is large, by the central limit theorem, it's much easier. However, when the sample size is small, we will need to use the t distribution to do this. So this is the end of this videos, and in next videos I will start to talk about more confidence intervals, but not for our population mean, but for our population proportion. So please subscribe this channel, and I will see you in the next video.